The Professor's Digital Dojo.
Okay guys, welcome back to the channel, Professor's Digital Dojo. Yeah. Alright, so what we're going to look at today is, it was a request from Cooper um, about creating the particle system using our graph editor. We've used it to create points on strands and strands and strands around strands and these other abstract forms. However, we do have particle system built into Maya. If we go into our FX menu up here, you'll see that we have all of our nucleus system, and we can create something called in-particles. Now, whilst in-particles are very useful for a lot of things, I find they're a bit antiquated, and actually working with particles in the Bifrost graph editor is, to me, a far more sort of flexible system. What I like about it is there are fields and behaviors that we can build into the graph network that we just cannot sort of create with an in-particle system. Now, if you're interested in seeing how in-particles work, I'll certainly do a tutorial on that, or I'll show you guys, demo that. I do use them. Like I said, it's not something that I never use. However, it is something that I find is, again, far less flexible, less enjoyable, and less aesthetically pleasing than working with the Bifrost graph editor. And frankly, once you start to get your head wrapped around nodes, the Bifrost graph editor is just quite a bit easier to work with. Now, if we create a new graph, I'm going to pull this up. I just pulled up the Bifrost graph editor window. We've got a new graph here. I'll zoom out a little bit. I'm sure this is nauseating and annoying to you guys. I'm doing my best, though, to kind of show everything on screen when I can. So we have our Bifrost graph. And of course, I could create a mesh object in here. So to create a particle system, we first need an emitter object. An emitter object can be a mesh or actually a curve. So we could draw a CV curve here, and that would be our emitter object. We might look at that in a sort of part 2 tutorial. But for part 1, we're simply going to use a mesh as our emitter. Now, I can create the mesh directly here, as you've seen in the Bifrost graph editor, or what I much prefer, and this is one of the reasons I love working this way, is I can create a polygon prim. I'll do just a platonic solid for now. It can be anything, and I'm going to give it a spherical shape. But the reason I'm also doing this is not just because it's a sphere. The reality is I tend to manipulate these a lot when they're emitters so that they're a bit more interesting, and hopefully you'll see what I mean in a little while. The reason I'm giving it these subdivisions, though, is because it will emit, pardon me guys, my apologies. Took a moment to silence that phone. I think I did. Anyways, so again, going back to the reason I like working this way is if I've animated my emitter beforehand or anything, it can easily be added to the graph, and I really, really like that. So we're going to have this sort of, I think we're going to have this particle system moving, you know, I think I've done it a couple of ways. I could have it traveling through space. I think what we'll do is let's have it move in an arc this way. I'll show you a nice trick. To get something animated in that fashion, we'll just kind of go the size of the grid here. I'm going to put it right there. And again, I want it traveling sort of in a full circle. We might make that a bit more interesting, but for the moment, let's do that. And the easiest way to do this is I generally use locators a lot and parent them to my shapes, and I group things to themselves. And I'll show you what I mean. If I hit Control G, I have now grouped this sphere to itself. Yep. And that means its transform point is now dead center of the grid. And so when I rotate it, I'll set rotation point here. Actually, let's set our first key. Let's let everything exist for about 1 second, 24 frames. We'll set a key there. And then I'll let it rotate 360 degrees basically, okay? So let's move down and let's give it about a little over 10 seconds, somewhere around there. Go. Boop. So we're just going to do one full revolution, and I can go in here and make sure to set that to negative 360. And there we go. So we'll have a nice loop happening. There we go. And this is the way I like to animate things. Generally, trying to animate it any other way would have been a pain in the ass, and I don't want to do that. So we're going to let it just run out that way. Running a simulation. Before, with the threads and all that, we weren't really running simulations. We were running mathematical probabilities through the graph. However, when we run a simulation, we have to make certain that our timeline is set in a specific way. I need to right click on it, and under playback speed, you have got to make sure that play every frame free is ticked. If you accidentally have it ticked in real time, Maya will, the simulation will fail after a few frames or run erratically, not run at all. It's a lot of things going wrong. The reason we need play every frame free is because when Maya is doing a simulation, the physics engine inside needs to be able to calculate one frame at a time. So we have to make sure that's set. So now that's set, we're great, we're grand, we're good, we're ready to go. Here is my Bifrost graph. Pull it up over here. That's an easy place for it. And I will middle mouse drag my emitter or whatever geometry I have into my graph. Now, we have our emitter shape here in our graph. And now let's put in, I'm going to hit our tab key, type in basic, and we're going to get a basic particle graph. There we have it. Now, the basic particle graph, if we double click it, because this is a compound, you'll notice there's a lot of stuff inside of it, right? We need to be able to access this stuff sort of outside in the other graph. It's just easier that way. So I'm going to tap back to this tab right here, and instead of having to double click it, we're simply going to right click and say explode. Boom. And it certainly does. It explodes it out, and now we have access to all the bits and bobs that we really need to make this thing work. So first things first, I would like to plug my emitter shape, whatever that may be, into the source particle's geometry. So this is like our probe geometry right here. I can then plug my particles out into my output. Things won't really be behaving the way we want just yet. Let's minimize this and take a look so you can see. However, we're going to do a lot of tweaks. Now, boom, you can see. There we go. Our particle is particling. Our emitter is emitting. All of our stuff is doing exactly what we're hoping for it to do. Now, I want to do a few tweaks, and also just to show everyone some practical things that we do here with a particle system. So the first is I'm going to create a polygon primitive plane, and we're going to use this as a collider. Now, you don't have to use a collider. However, I would be remiss if I didn't show everyone how the colliders worked. I'm going to sort of put it down here a bit. And whenever I'm making a collider, especially like a plane, I want to give it more resolution. It makes the simulation a bit more efficient. In other words, it's giving it more resolution to collide with, and it takes less steps in calculating to make that happen. Again, I'm going to come here in my channel box, and not channel box, sorry, my outliner, and you can see I've got channel on the brain. I meant to type in collider. And I can middle mouse drag my collider into here, and then the collider gets plugged into, well, you guessed it, we have a collider node here, and we're going to plug the geometry in right there. Now, if I were to play this right now, you'll see that these particles collide, with our plane, and there we go. And hopefully you can see the practical reasons of why we would want this to happen. So I'm going to remove this collider, however, just because I don't want that. This is not something that I want to muck about with right now, and I'll just Control H to hide it in our scene. We can delete it from here. In fact, I'll just highlight it, hit delete, because we're going to do something far, far, far more interesting, of course, right? So first, let's go to source particles here. Let's look a little bit at what we've got. We can enable the start frame, and I'm actually going to set the start frame to 24. that's when our animation starts. So I kind of would like everything to stay still for a bit and then start emitting when it starts moving. So I can set start frames, and I can use an end frame as well. I can say, hey, I would like you to stop emitting particles at frame 200 or whatever. The other thing I'm going to do down here, there's a lot we're going to change in here, but I'm going to turn on live forever. So that means these particles are going to live, you got it, forever, so that they do not decay or die off. These particles will live forever. Now, I'm doing that because we're doing something kind of abstract. However, there are many times where I definitely want to give the particles an age limit. I would say, for a lot of practical reasons, practical effects and things we're doing in there. For now, for what we're doing, I want them to live forever. The next thing is I want to increase the rate. We're going to go to 1,000 for now. And we're going to decrease the size. So if I hit play right now, you can see that these particles are rather chunky. They're large. Let's go from 0.1 to 0.05. So now you can see our particles are much smaller. The reason I'm going to do this is we're going to play with the viscosity. I want to create something that's like this organic weird shape that's moving and has kind of a life to it, all right? And also, just so you can see how these things work, I can pump this up to like 5,000 and we'll get a ton of particles, as you can see right there. Now again, I am on a high resource system. Nonetheless, the Bifrost graph editor is programming efficient. It is resource efficient. It is not something that should, kill your laptop. You may have to control your particle counts a little bit more thoroughly. However, I really don't think it's going to be something bad. I can also come down here. I'm going to reduce particle speed to 1 instead of 2. And again, that's an aesthetic choice. I want them just to emit a bit slower, and so that you guys can also understand emission principles. It's important for us to know that. So we can control how quickly the particle shoots out. Let's say we put it on 5. How quickly the particle shoots out of our emitter. Let me rewind here. There we go. And you can see it's also emitting a lot more because they're coming out so much more quickly. Let's pop this down. Let's do 1.5. Let's sort of split the difference there. All right. So that's our source particles. So there's a lot we can tweak in here and play around with. Collider you've already seen. That allows us to plug geometry in that will interact with the particles. Particle solver settings. Now this is important. This is where really a lot of changes and tweaks can be made, especially if I'm using these particles within a master scene, a scene where I really need these particles to have a practical application or effect. The main thing that I use this for right here is, one, I'm going to turn gravity off for what we're doing in our solver settings. So this is our physics engine that drives the simulation. I don't want gravity on, and I also could come in here and change the shape. We are going to stick with sphere. And let's look what happens when we turn gravity off now. You can see these particles just start to expand, and with them living forever, we are at this point calculating quite a bit of data. Not a big deal. We can deal with that. I'm going to zoom out just a little bit here. Now don't worry, we're about to make this a whole hell of a lot more interesting and a little bit more complex, but that's okay because you got this. Not a big deal, right? So what we want to do now is I would really like to influence this simulation. I would like things, like I said, to look, I'll do something similar to kind of the example file that I posted on YouTube of these particles in space. To do that, I would like them to get influenced by some fields. Right now, they're just spitting out into nowhere. And now, there's a couple of ways we can affect how these particles behave. Let me kind of neaten this up a bit. There we go, so it's easier to see. So one of the things you can see over here is under our simulation, we have a plugin for influences. So we can say like turbulence, we'll pull up turbulence influence. I'll even just type in influence really quickly so that we can see how many different influences we have. So we've got Arrow Einstein. Anytime you see influence, that means it can be plugged into this influences right here. Buoyancy, collide field. Oh, so you can see we've got a lot. But we're going to go down. I like this turbulence influence here. We're going to plug that into influences here. And we'll leave it just at its default for a moment. If I hit play, whoop, let that go back. There we go. You can see that now turbulence is affecting how the particles behave in space. If I increase this turbulence and tweak the frequency and maybe give it a little bit of drag. Drag is sort of like wind resistance. That's the easiest way to think about it. You'll see now that, of course, again, we can control how these particles behave in space. Now, one of the things I did, however, is I created a particle system that was controlled by a fractal turbulence field. Now that requires a little bit different tweaking. So what we're going to do is we're going to undo this influence right here. In fact, I'll just delete it out to keep this graph pretty clean. So I'm going to hit tab and we'll type in fractal. I'm going to do a fractal turbulence field. Now, there's a little bit of an issue. If I just try to go and bosh this in right here into influences, you can see that the simulation is sort of like, nope, that doesn't work. And one of the reasons is this is a fractal turbulence field before we put in a turbulence influence, which means it was already an influencer. So we have to kind of create a node here that is just going to be an intermediary that will convert this fractal turbulence field data into influence data that this simulation will understand. So that's pretty easy. We're just going to type in influence. There we go. And I want influence set property. So that's the node that will translate this fractal turbulence field into what this simulation needs. We're going to take this noise field and we're going to pop this into value like so. And then we're going to bosh in right here into influence. And you can see that everything's happy. All right. So super stoked. It's like, hey, everything's working out. If I hit play, however, we're going to notice that there's no fractal turbulence field thing happening. Let me rewind that and we'll hit play. And so you're kind of like, all right, so what's going on here? And that's because we've got to set just a couple of other properties really quickly. And to get that property, we need to go and investigate a couple of things really quickly. Once again, I'm teaching, so normally you'd be able to do this pretty quickly. I'm explaining things, so it will take a little bit longer. What I want you to do is between the simulation and the actual output, we're going to create a watch point. And we're going to do this by right-clicking on this line and saying add watch point. That watch point pulls up a lot of properties of all the particles that are traveling through to the output. Now the one we're really worried about is point velocity. So remember that point underscore velocity. I can right click and remove that watch point. Now I'm going to go over to set influence property, and under key I'm going to type in point underscore velocity. And so now the influence property is going to look for the point velocity created by the fractal turbulence field, and it's going to pass that information on to the simulation. So now if we hit play, we're going to get a very different behavior. There you go. You can see that fractal turbulence field affecting the particle system. Now that's kind of, pretty much it right there. The rest is us art directing this and tweaking it. In other words, I can increase the magnitude of this field to maybe 4, 5, 6. I can tweak the frequencies. I can play with more higher or lower particle count. So you can see that by tweaking that field scale, the fractal turbulence field, rather, magnitude here, that we're creating a higher volume of fractal turbulence within this space. Now, this is a really, really interesting way to work. What I would do at this point, of course, is then we can render this. I'm going to hit F on my keyboard to kind of focus in. Let's minimize this for a second. And we'll right-click and add favorite material, AI standard surface material. I'll leave these white for now, and we'll create really quickly a sky dome light. Turn that down to 0 for camera, and under viewport I'm going to make it sky radius 0 again, because I just don't like seeing it visually. It gets in my way. And we'll put an HDRI onto here, and let's see what we've got. Again, there's a lot more we can do. However, I want this to be pretty straightforward, and then the experimentation can happen on your end as you begin to play with. Let's do this one right here, and then under color balance, make certain to always tick alpha is luminance. And we might tweak this a little more. I just want to see what our render looks like for the moment. I'm going to have to do some edits. I want to tighten this video and shorten it up a wee bit too, so let's just see. Ooh, there we go. So that's a pretty cool looking structure. I think, however, really quickly, before I let you go from this tutorial, what we may do is here under source particles, let's do a couple of things. Let's increase the rate to 8,000. And here we are. Let's take a look at our render. I increased our points. I actually brought viscosity back down to just 0 because I do not feel like sitting here and waiting for this sim to run. Let's increase our resolution for our render, just so that you guys can see the actual nice final here. And I'm going to go to 2K square. Under our renderer, I don't need volume indirect, I don't need subsurface scattering, and I don't need transmission right now. And under our view, camera settings, I'm going to turn on my resolution gate. And then because I'm doing 1K square, again under camera settings, I'm going to say, can you fill? That way I can establish a nice composition. There's one more thing we'll do here before we're done. I know this tutorial was a bit longer, worth it though, hopefully, is I am going to increase this to about 10,000. And again, you don't need to freak out. Stay within your computer's sort of comfort zone. However, you'll see that this runs fairly efficiently. Now, as the particles start to build up on screen, things will slow down just a tad. However, you can see that this is, once again, much like MASH, designed for fairly efficient calculation. In fact, this is far better than Maya's nominal and normal nucleus system, say, in particles. Sorry, that was a weird way of saying normal. Here we go. And so I'm going to let this run out all the way to the end. And remember, I can keyframe all of those aspects like the fractal field and things like that. So we'll pull up our render window, and now let's just take a look-see at what we've got. Oh, that's lovely. Beautiful. And there you have it. Now if I wanted to, I could increase or decrease, again, the scale of these particles. If I needed this to behave a bit more fluid-like, last thing we'll do here is I probably would go in and maybe make the size of these particles, let's go 0.1, and we can run that again, and you'll see that they'll sort of run together a bit more, and this will seem a bit more fluid-like. In fact, I'll kind of stop it there, and we can just pull a quick render from that spot. There we go. So hopefully this makes sense to everyone. If there is any confusion, please let me know. I will gladly sort of help you out. And here's the last thing I want to show you is if I am super chuffed and I really like my result and I don't want to have to do it over and over and over again, I can select all of the nodes in my graph and I can come up to create, and I can publish this graph. And what that means is I'll give it a name, and once I've given it a name, I'll hit publish. And then I can come up here to my Bifrost browser, and at the bottom under users, you'll see that I have a bin. This is a bin that I created and named it after myself. Double click it, and I have certain sort of graphs that I really liked in the end, and I publish them here, and then I can just import them into an existing Bifrost graph. So if I wanted to, I could do so here.